Hello everyone and welcome to the latest in the London Digital Classicist seminars. I'm delighted to welcome you today, and in particular to welcome our speaker, Dr. Heidi Jauhiainen. She's a rather marvellous mixture of computer science. Welcome to the latest in the London Digital Classicist seminars. Sorry, I've got echo here. Let me just, delighted. There we are, sorry. Let me start again. I'm really delighted to welcome Dr. Heidi Jauhiainen to speak to us today. She's a fabulous mixture of computer scientist and Egyptologist. Her first degree is in computer science, and then a PhD on feasts and feasting in the New Kingdom village of Deir el Medina, where the workers building the royal tombs in the Valley of the Kings and the Valley of the Queens lived in the 13th to the 11th centuries BC in Egypt. And since then, she's worked on a really impressive range of computational linguistics projects, ranging from Finno-Ugric to Romanian to ancient Babylonian or Akkadian. But I think she's now back home, as it were, combining her first two her interests. Heidi is a member of the very large Centre of Excellence based at the University of Helsinki in Finland on ancient Near Eastern empires. But this is her own project she's going to be talking us about today, which is slightly separate but connected, as you'll see. And I'm particularly interested, as an Assyriologist and working on cuneiform texts, to be listening today to her talking about hieroglyphic texts and machine readability for Egyptologists. So Heidi, please, thank you so much for coming, and I'm really looking forward to your talk.
Thank you, Eleanor. And thank you all for having me here at the Digital Classicist seminar. Eleanor said, tonight I will talk about machine-readable hieroglyphic texts, and hopefully I will explain why we need such texts and why there are so few of them. But I would like to start by explaining who I am and why I'm interested in machine-readable texts. Let me see. There we go. So Eleanor already explained a bit, but I'll explain again. So I studied Egyptology at the University of Helsinki first. And in 2009, I defended my dissertation on feasts and festivals at Deir el Medina. And Deir el Medina is the village where the men who built the royal tombs in the Valley of the Kings lived with their families. The village was occupied during the New Kingdom of the ancient Egyptian history, so the second half of the second millennium BCE. And the ruins of the village were excavated during the first half of the 20th century. And you can see them in my background picture. Now, many of the men living in Deir el Medina were literate, as they did not just excavate the royal tombs, but they also decorated them with texts and pictures. So tens of thousands of texts were recovered in the excavations in the village and also in the Valley of the Kings, where the men worked. And those texts tell us about the work in the royal tombs, but also about everyday life in the village. Now in Finland, we do not have any positions in Egyptology. So after my dissertation, I moved on to study computer science. And I graduated as Bachelor of Science, but only after I had already started working in a project where we were crawling the internet to find texts in small Finno-Ugric languages. And later I worked with Assyriologists and language technologists to study the meaning of Akkadian words using methods from language technology. So like Eleanor said, I have been working within digital humanities for years already. And last year, our Assyriological project ended, and I wanted to get back to Egyptology. And I wanted to use my experience in studying large numbers of texts with computers on texts from Deir el-Medina, or at least on texts from ancient Egypt. But when I started to plan my project, I realized there weren't any openly available machine-readable hieroglyphic texts. So the object of my project, which started at the beginning of this year and which is funded by the Finnish Cultural Foundation, the object is to produce machine-readable texts. Now, in Assyriology, there are several online corpora of texts. And in our project, we used texts from ORAC, or Open Richly Annotated Cuneiform Corpus. And ORAC is a platform where projects from all over the world can publish online the cuneiform texts they are working on. Often the texts have already been published in books as well. And last time I downloaded the text from ORAC, there were over 17,000 texts, and more is added all the time. Now in ORAC, for each text, one sees the transliteration of the cuneiform signs into Latin letters, and often there's also the translation of the text. And most of the texts have been annotated, and by hovering over a word or clicking one can see more details. And it's possible to download the text to your own computer as JSON files. Now, when studying the meaning a word has in different contexts, you would have to collect all the instances of that word. And traditionally, one would probably study only one or a few words, and still it would take a long time. With machine-readable texts and language technological methods, we could study the use of several words in thousands of texts, and quite fast. But of course, we needed as many texts as possible, so ORAC was excellent for us. With digital methods, we would get lists of words and numbers as a result. And these are difficult to interpret. Here on the left are some of our results from the fast text method for Akkadian words. So because these are difficult to interpret, we visualized our results as graphs. And there we could see patterns and connections. And then we studied the words in their original context to see why these connections existed. And to make this easier, we put all the ORAC texts in an online concordance tool called CORP. ORAC in CORP, as we call it, is hosted by the Language Bank of Finland. And there we could easily see the various contexts a word was used in, as all the instances are shown on their own lines with the original context around them. And from CORP, we could, with one click, go to the original text in ORAC. So with machine-readable texts, one can study large numbers of texts fast and find statistical regularities or maybe abnormalities that one would not otherwise see. But one can do other things too. One can, for example, identify languages or dialects or text genres or sentiments and so on. With machine-readable texts, one can train new digital methods. For example, in order to use optical character recognition, or OCR, on hieroglyphic texts, the method would first have to be trained with lots of annotated texts. But one does not always need a lot of machine-readable texts for them to be useful. On a smaller corpus, one can use search function and study frequencies of words or phrases. And one can study regularities of how words or signs or phrases appear in those particular texts. As I already mentioned, when I started planning my own project in 2019, there were no openly available machine-readable hieroglyphic texts. But I'm talking here about dynastic Egypt before the Greco-Roman period. I understand that there are more resources for the latter period. And I'm also talking about texts that you can actually download to your own computer. There are actually several excellent online resources for ancient Egyptian texts and words. For the Deir el-Medina texts, there is the very valuable Deir el-Medina database with information on the texts from the village. I use it all the time to check where a text has been published and discussed, and to see what names and terminology is used in it. But you cannot use it, for example, to find texts that use a certain word, unless, of course, it happens to be one of the terminology words. Some of the Deir el-Medina texts have been published online in the so-called Deir el-Medina online service. And here you find a full study of each text, pictures, transliteration, translation, and comments, and so on. And there is even additional metadata for each word. And you can search text with various criteria. But you cannot download the text or download the results from the research, the search that you have done, or see any statistics on words. Now, Ramses Online is an interface built by the Ramses project at the University of Liège. And it contains texts written in late Egyptian, which is the language used during the New Kingdom. So at the time, Deir el-Medina was occupied. This interface was published in 2015, but is still now a beta version. The Ramses project has been continuing to produce annotated late Egyptian texts. They just do not seem to be in the online portal. In Ramses Online, one can search for a word and then see all the different attestations of it listed line by line with the context, the sentence of that word on that line. And the words and texts have been annotated, but again, you cannot download anything. Thesaurus Lingua Egyptia is more like a dictionary. There you can look up for words, but you do not get to see the context they are used in. But you can get frequencies of words in different corpora or in individual texts. And the really good thing about Thesaurus is that the words and some texts were published by Simon Schweitzer last year. So they are now downloadable from GitHub as TEI files, and this year also as JSON files. So finally, some data that you can actually download for yourself. No Terra Medina text here, though. Now I would like to say a few words about hieroglyphic texts and hieroglyphs themselves to give an idea why making machine-readable hieroglyphic text is not so straightforward. Oops, sorry, there's the link to Simon Schweitzer's GitHub account. So hieroglyphs, they were generally used in monumental texts. And hieroglyphs can be written in different directions, from right or from left and from up down. And the direction usually depends on the pictures. So this person's text starts from here. I hope you can see my cursor. And this other woman's text starts from here and goes to the other direction. You can easily tell the direction from the living creatures amongst the hieroglyphs. So persons and animals, and you always approach them from the front. Now, when writing literature or letters or administrative texts, ancient Egyptians usually used so-called Heuretic writing. And that is a cursive handwriting that is based on the hieroglyphic writing. Just faster written hieroglyphs, kind of. Heuretic could also be written from up down, but at least in the non-literary texts of the New Kingdom, it was generally written from right to left, so this way. And the red spots here indicate verses, as this is a literary text. Now, in Egyptology, hieroglyphic documents are generally published in books with either a picture or a facsimile, so a line drawing of the text on the object. So here is the previous text as a facsimile on the left. And then this hieroglyphic text is usually transcribed into hieroglyphs. In the older publications, this was also done by drawing by hand. But in new publications, this is usually done with hieroglyphs produced with computers. But they end up being just pictures in the book or article, even if it's a PDF or published online. Now, hieroglyphs have different functions, and one sign can have different function in different contexts. Sometimes a sign can be used to denote what they depict. Like here, on the left, the sandal strap, it can be used to denote the word sandal strap. But most glyphs also have a phonetic value, and with that, other words with the same consonants can be written. So, because ancient Egyptian is an Afro-Asiatic language, and like in Semantic languages, only consonants and semivowels are used in writing. So the sandal strap sign Ankh, which starts with an Ein letter that we just pronounce A, so Ankh, it can be used to write the word life. And some signs have several different phonetic values, so often other signs are used to show which phonemes to use. So the word for life is often written using the sign Ankh, plus a sign n, and a sign having the value h. So ang. So-called determinatives are used at the end of the word to tell the different words with the same consonant support. With the sitting man, ang becomes a living person. And with a man pointing to his mouth, it becomes an oath or the verb to swear. The same word is not always written in the same way. In monumental texts, it depends on the aesthetics and space. In hieratic text, it depends on the preferences of the scribe and also on how many times he's already used the same word in that particular text. And here are 3 examples of how you can write the phrase on this day, herupen. The 2 lines in the last example are just a hieratic way of indicating the usual signs here. You know what I mean. Now, hieroglyphic text does not indicate word boundaries nor the end of sentence. And as you have perhaps noticed, hieroglyphs were written in kind of boxes. A sign is often above another sign. And in order to display the signs properly in books, the hieroglyphs are nowadays encoded with Latin letters and numbers so that computers can handle them. And this is different from transliteration. Transliteration does not tell the position of signs in regard to each other, nor does it tell which signs were actually used for the word. The codes used, they come from the so-called Gardiner sign list, which is the standard reference list for Egyptian hieroglyphs. The list was compiled by Sir Alan Gardiner in 1927 for his grammar book of Middle Egyptian. And the letters refer to various categories of signs, while each sign has a number within the category it belongs to. And here the category D, which contains the various signs depicting parts of human body. It is also possible to use the phonetic value of a sign as a code for it, at least if the sign only has one value. So now it resembles more the transliteration of the text. And to write it that way, it's actually easier for Egyptologists because they are used to transliterating hieroglyphic texts. But you can have a mixture of these two. The most often used encoding is called manual decodage, which has been kind of a standard since 1988. In order to get a sign above another one, manual decodage uses a colon. And to indicate that signs are next to each other, it uses an asterisk, so the star, like in the example in red here. Now, the problem with manual decodage is that you cannot indicate different sizes of signs. And sometimes a sign is nested inside another one, or is actually over another one. These two signs inside the red circle, they are nested, but they are actually one sign in the Gardiner list. So they have just one code in the encoding here, U4. But here on the left, these two signs, the snake and the hand, although they make a very often used word to speak, they do not have one code or one sign. And this second example is how they are usually written in hieroglyphic texts. So the snake is sort of wrapping around the hand. But this first example here is how Manuel de Codas puts the signs. Now, Manuel de Codas is used in various softwares that are often operating system specific. And in each software, these things have been dealt differently. For example, in JSesh, which I've been using, it's possible to manually position and resize the signs. But then the coding, the encoding would look something like this. In JSesh, there's also ready-made signs where a glyph is, for example, over another one, or you can use the @ sign, like here, to do this. But as I said, these measures are program specific. Mark-Jan Nederhoff proposed a new encoding system, which he called Revised Encoding Scheme, or RES. And with RES, the signs can be nested and positioned over each other in multiple ways. And the position is not absolute, but in reference to other signs in the sign group and to the top, bottom, start, and end of the kind of box they are in. Now, RES has not been widely adopted by Egyptologists, and the main objections to RES have been that it takes too long to write because of the precise commands, and it is also considered irrelevant because Egyptologists usually use graphical interfaces to type hieroglyphs and are used to Manuel de Codas coding used in them. And also because the coding has just been a phase when publishing the text, and the coded text has not been needed after the book or the article is out. It's actually sometimes thrown away when the book comes out. Unicode is another kind of encoding. Since 2009, the Unicode has included over 1,000 hieroglyphic signs. However, it was only possible to position the signs one after another, like in this lower example here. In 2019, the so-called format control characters for positioning the hieroglyphs were introduced in Unicode version 12. And for me, Unicode would seem to be the most reasonable and most stable solution for encoding, so that the text can also be used in other projects in Egyptology and in the future. But producing Unicode hieroglyphic texts with, producing them is not easy, since the hieroglyphs are outside of the so-called basic multilingual plane. That means that unlike many Unicode characters that have the 4-digit Unicode hex input, hieroglyphs have 5 digits. And here you see Coptic characters that have 4 digits and hieroglyphs with 5. And for a computer to handle hex input with 5 digits, it has to first be told to consider it as actually 2 separate jars. I know of one special virtual keyboard to write Unicode hieroglyphs, but it does not seem to have the format control characters to position the signs, not yet anyways. There are also fonts for Unicode hieroglyphs, but they require specific tools depending on where you want to use the font in, whether it is a web page or a document. So you cannot just download the font and start writing hieroglyphs into a Word document, for example. Another problem with Unicode is that Mac operating system does not support showing the format control characters. Sorry, I'll show you here. This example does, in fact, have the format controls. But since I have a Mac, the text is just a list of signs. The format controls are there and can be read by the machine, but they are not visible. Now, the different kinds of encoded hieroglyphic texts are machine-readable, and Egyptology has thus a tradition of producing machine-readable texts. Unfortunately, there is no tradition of publishing those texts, and instead they are sometimes even discarded. But some encoded hieroglyphic texts have been used for developing digital methods for handling hieroglyphic texts. For example, Nederhof designed a method for automatically aligning hieroglyphic texts. There are often slightly different variations or versions of the same literary text, and this method aligns the different versions and their transliterations and translations. In another method, Nederhof aligned differing translations to one hieroglyphic text. You also need encoded text to build automated transliteration. There was some earlier attempts to do this using only a few texts for training and testing the method. But just now, Serge Rosmorduc has published a method for automatically transliterating late Egyptian texts. So that's again the phase of the language used during the New Kingdom. Now, Rosmorduc's method, it uses deep learning, and the data for training the method, it comes from the Ramses project. And the transliteration is produced with an encoder decoder, and the input for it is manual decodage encoded text. And the method is now actually available in Zenodo. So the object of my project, which started at the beginning of this year, as I said, is to publish the data from my PhD in machine-readable form. And I used about 400 texts for reconstructing the festival calendar of Deir el-Medina. I used the text mentioning feasts, but also text stating or indicating whether a day was a working day or a free day for the tomb builders. And in the dissertation, only the relevant passages were, of course, mentioned. But I want to publish the whole texts as an appendix to a publication of the feasts at Deir el-Medina. The form Egyptologists are most familiar with and can read with most ease is transliteration. But since there was no automatic method for producing transliteration that could be used for practically any texts, I planned to build one. And since the OCR of hieroglyphic text is not yet available, I needed machine-readable texts to build and test the method, which meant encoding the texts first. And I have chosen to produce encoded texts with chasers. And chasers is one of those platforms for producing hieroglyphic texts with manual decodage. It has, by the way, also been developed by Serge Rochemorduc. As chasers is made with Java, it is a standalone software that can be used in different operating systems. And it is also open source, so you can download the source code from GitHub and make your own adjustments on the program. I have added some signs that are included in Unicode, but were not in chasers. From chasers, it is possible to export the texts as pictures, vector graphics, PDFs, and so forth. And you can also copy out the manual decodage code, and you can copy the text as Unicode. In fact, most of the hieroglyphic words and sentences in my examples and the manual decodage codes and the Unicode have all been produced with chasers. Now, of course, it seems that I can use the automated transliteration method built by Serge Rochemorduc, which is great. Rochemorduc had a much larger training corpus as he was using the texts produced by the Ramses project already. They've been doing that for years. It would have taken me a long time to get the method working with just a few texts. And I have tested Rochemorduc's method, and it seems to work on the text I have been working on. And now I can get faster to actually using digital methods on the Deir el-Medina texts. Of course, the automatically produced transliteration is raw transliteration, which needs to be checked and in places corrected. So the plan is that I will go on encoding the text with manual decodage. It is good that I chose to use chasers, which gives me manual decodage encoded texts, as this is what I need for using the Ramses method. But I will need to develop a workflow for producing the transliterations with the Ramses tool as automatically as possible. A manual decodage text should be read from a file and the transliteration written out to another one. And I will also need a platform where I can compare the hieroglyphic or hieratic text with the transliteration and make the corrections. The texts that I produce will be published in many different versions. I will publish the glyph files produced in JSS so that the text can be worked on and modified later. I will also publish the manual decodage code for use in digital methods. And hopefully in the future, the Unicode will be easier to handle and work with, so I will publish the Unicode versions also as well. And of course, the automatically produced transliteration. Even after the correction of obvious mistakes, this will still be raw transliteration, as I will not study each text. But I hope that they will be useful for Egyptologists anyways. And all these different versions of the text will be offered for free download. So that was all I have.
Heidi, thank you very much. Sorry, it took me a few seconds to mute. That was absolutely fascinating, and I think very helpful for people who are not so familiar with the complexities of hieroglyphic script and the vast range of encoding options that have been tried and tested over the last, 20 years or more, and the frustrations there have been with them all. And one of the things that strikes me is that there are a lot of these closed corpora doing lots of different things. To what extent have Egyptologists ever sat down and talked about the possibility of doing something like Heuretic, which has been inherently collaborative, as you said? That grew out. Okay, hands up, that's my baby in some ways. It grew out of a funded research project that I had in Cambridge. We started in 2007. We had corpora already, but building the sort of editing tools and just the social consensus to contribute legacy material. So as you said at the beginning, a lot was people gave us material that had been encoded in other forms, and a lot of, certainly in the early days, was just about converting that automatically and getting it online. And nowadays people tend to produce on Heuretic in order to publish in book. In fact, I've just spent the whole day finalizing a name glossary for something that's coming out soon. So that, obviously, that began with a bigger sort of, there were 3 of us essentially in different universities working together on it. So it didn't take a lot of labor. Sorry, this is really waffly, but what I'm asking is, I think, what potential do you think your methods will have to be scalable so that it doesn't become just another one woman, single project thing, but can either contribute to or be the hub of a larger resource?
I think the Ramses project is something that is trying to do a bit like what's been done with Heuretic. The Heuretic texts have not always been freely downloadable. When we were planning our project, we asked for the text and were given them, but back then they had to be sort of like, we have to make you a package, XML files, and here it is. But we were told that yes, the plan is to have it so that you can download them easily, and now you can do that. There's the JSON files, and it works well. The Ramses project, they have been working maybe already for 10 years to produce the texts. And it's not just some people who are paid by the project, but it's possible to be sort of to get to actually work on the texts if you want to, and you have the ability to annotate the texts. As far as I understand, it's possible to go work with the project. The thing is, I have a feeling that eventually they will publish the more texts online, and maybe hopefully also then offer them for free download. What I understood from Rosmoduk's article on the automatic transliteration, because he has the data from Ramses project, is that the words are annotated with transliteration, but the sentences are not. So anyways, even if you could just download the texts, you would still need to perhaps make corrections to the transliteration before you publish the text. So maybe if I can develop a tool, some kind of platform where you can do that, compare the texts and do the corrections, this might be of help for Egyptologists in the future, if the texts are downloadable and then you want to publish some text or texts sort of more in a more correct way. Because, for example, what I didn't mention here is that there's some words that are kind of holy, that are written before other words like God and stuff like that. You write the word first, although it actually comes after the other word. So the Egyptian language is Medu Necheru, the words of God. But you write the God word first, and then the Medu. So and those are not, when you if you download the data from Ramses online, then those would be in the wrong order. This kind of mistakes, and of course the automatic transliteration also makes mistakes.
Yes, yeah. So I think in that really helpful answer, I think you've pinpointed a couple of big challenges for these long-term collaborative projects. One is just the sheer duration, when projects start and then new technologies come along. So, I mean, in the case of the JSON files for ORAC, for instance, I mean, that JSON wasn't a thing when we were first funded. And so your group was one of the first to need them. And of course, that led to us, the collective, then be able to deliver that. And I'm sure that's obviously a challenge for some of the older Egyptology ones. But then there's the question of transliteration style and what counts as correct. And every project has its own sense of correctness. And one of the challenges we have in ORAC is that we have to allow projects to do their thing and yet we've somehow got to harmonize it. So we're just finally developing a tool that will search across all of the corpora within ORAC itself. But given that everyone has their own transliteration styles, that's been a real headache. But if we don't do that, and how can you enforce a style and say to people, oh, you can't play with us if you don't do it our way? And nor can you, and it's just the sheer time involved in going and checking other people's work, never mind the sort of the social politics of that. Anyway, yes. There are questions I'd like to put to you, instead of me just talking. First of all, a comment from Rodrigo Lima, who asks, how do you deal with changes in the Egyptian language? I'm asking this because in my research, I try to write in Phoenician using Unicode, but there's a lot of variation in time over time. So I'm not quite sure whether he means the language itself or changes in script, because again, those are two big and yet related issues, aren't they? And there's something that we as cuneiformists face, particularly with Unicode, which just captures a snapshot of script use rather than its evolution.
Yes, that's. I'm really lucky that Serge Rosmonduk has done his tool with the late Egyptian texts, because they are different from texts from other periods. The Thesaurus Lingua Egyptia, it has texts from different periods, from Old Kingdom, from Ptolemaic Egypt, but they are, first of all, there's of course all these different phases of the language, and then they are very different genres of texts than what I'm using. So the Ramses Online is the same kinds of text, and they have been using, I understand, a lot of Deir el-Medina texts, so that helps. But like before I learned about the Ramses tool, I was happy that Simon Schweitzer had published the words from the Thesaurus, but we both agreed that I might not be able to use the words so much. I wanted to use them to help teach the method, but the vocabulary is different, at least in those texts in the Thesaurus, and only then time will show, I suppose, if Rosmonduk's tool can be used for other. I haven't, of course, tried it on different kinds of texts, but he also plans to teach it with other kinds of texts and maybe from other periods. So when you have enough texts from different periods, then it doesn't matter anymore so much that they are from different periods. I mean, in the Assyriological project that we had, we well, first we took all this data from ORAC, all the Sumerian, all the different languages, not just the different Akkadian dialects, but all the languages. And there was enough data, and they were different enough, the languages, that it didn't really that much make a difference in our studies. Of course, then later we only took the Akkadian and we tried just Neo-Assyrian period texts or just all Akkadian, and so it didn't really matter so much what the period was. What made more a difference was the different genres of texts. So they seem to have different vocabulary. But if you teach a method with you have enough texts, and if they're from all kinds of genres and periods, then it doesn't matter anymore so much.
Yeah, that's a lovely answer. I mean, I say to my students, Aurac's rather stupid, but it has a very good memory. You know, you have to teach when you were putting a new genre or a new period or a new place in, it needs a lot of manual intervention. And then, you know, it'll go, and then it can do a better job than I can actually. And when I'm lemmatizing, if I've basically read the signs correctly, it will tell me how to lemmatize them. Often surprisingly usefully, actually. It's a lazy girl's translator. It's fantastic. Anyway, so I hope that's a useful answer. Yes, Rodrigo says thank you. And in fact, Simon Schweitzer is here as well, and he has made the best comment. He said, thanks a lot, that's very interesting. Egyptological Aurac would be so cool.
Can't hear Eleanor anymore.
Data in my GitHub repo is licensed. If anything, if it's about how to go about any aspect of putting stuff together, I'd be very happy, or my programmers, or Steve Tinney, who's the main sort of driving force behind. Really happy to chat about the logistics. I'm sure you're great at the coding. The social logistics are rather interesting.
Yeah.
Looks like we lost Eleanor momentarily. I'm sure she'll be back in a second. Maybe, I mean, with the promising discussion of the future Egyptological Aurac, can wait until she returns. But maybe I could ask a question that I was wondering about, which is maybe slightly technical and slightly naive. But I wondered, you were talking about the various different systems for handling hieroglyphics computationally, and you know, for display and for encoding and so forth, including JSESH and the other system you were talking about, and Unicode. And I understand, obviously, there's competing drives. You know, Unicode is going to be most compatible with more, you know, with more people in the future and so forth. But you also want something that works now and that you can display on all platforms. But I wondered, therefore, how easy it was to translate between these different systems, so that if you had encoded everything in a different system, you could produce the Unicode from it as well, so that when the tools catch up, that's more useful. Or are there differences in their conceptualization of the language that make that translation non-trivial?
Because manual decodage does not do everything. It's you can't do exact hieroglyphic text from that. Again, if it doesn't do it properly, then you know you can't know that it's actually a sign is wrapping around another one. So from that to go back is not so easy. But then from Unicode, if the format controls have been used properly, then you can probably go to the other one.
Mm-hmm.
And res, I think it's well, I think the format controls in Unicode are quite similar to what is used in res. I mean, Nederhof has been working on the Unicode too. He has been in the sort of committee to do that, and has had influence on that. So, but that's why I want to publish the Unicode already now, because the manual decodage, you can't really do everything. Although since I do the Unicode with can you hear?
We can at the moment. You disappeared for a few seconds. No, possibly disappeared again. Helena, are you back properly?
I'm back, yes.
Great. So
we're just on 6 o'clock. I mean, I hate to wrap up without Heidi here, but we should finish quite soon.
Yes.
So while we're waiting for Heidi, shall I give everyone a reminder of the next seminar, which I was just reminding myself of. So we're meeting fortnightly this summer. So the next seminar is at 5 p.m. UK time, 6 p.m. European time on Friday, the 23rd of July. And it's Daria Elagina from the University of Hamburg, who's from Project Encode. And she'll be speaking about modeling vocabulary of digital competencies for Project Encode. And we have Heidi back. Thank you. Sorry, we're both having internet glitches. It's okay. We are at 6 o'clock. Is there anything else that you'd like to say before we finish, Heidi?
Maybe I can just sort of end that thought that I was trying to say. So I want to publish the Unicode now, but actually, since I make them with manual decodage, the chases with the manual decodage, I don't have all the format controls there, so just the basic ones. So it's still a very basic Unicode. But in case, you know, in the future people start using Unicode more, then at least the texts are there. And anyways, for machine reading, like I said, when you have enough texts and you don't need all that information. Plus, if you are looking for regularities of signs used together or words used together, it's maybe, well, then if you want to know if the signs are used over another sign, above another sign, then you need to have that information. But you can do a lot of things without knowing that. So that's
also very promising then for the possible, you know, future Oraic, given that there's going to be better, you know, this is clearly improving as time goes by. Things are, this sort of thing is going to be much more possible, and that'll answer some of the questions we were talking about before. Yeah.
Yes, it's surprising how long it takes to do this stuff. I mean, I started working on this type of work in 1996. I just, not far short of my 25th anniversary of my first forays into SGML. This is how old I am, before XML was invented. And, you know, we're faced with this interesting contradiction, and we were working with texts that are millennia old over this huge span of time and range in a technology that was essentially designed for alphabetic European scripts, with new affordances coming every year, probably much faster than I can keep up these days. And so, and yet we're desperately understaffed. I mean, just as a discipline, there aren't many of us in Egyptology or Assyriology. There's an even tiny number of us who are competent and confident enough to engage with the digital humanities side. And there are even fewer of us like you who are coding directly. I mean, these days I mostly work with software engineers. And yet there's, you know, a huge demand, not just within our own disciplines, but with adjacent disciplines and students, and just the endless fascination that publics have for our field. So I think what you're doing is massively exciting. Really bodes very, very well. And I recognise that the sense of feeling that one's all alone, and that there's a huge burden of expectation on you. Nevertheless, I mean, we've seen already, just from the faithful few that are here, I think there's a lot of potential momentum for this, and I'd really love to talk to you more about possibilities at some point soon. So I think we should wrap up and just say just a huge thank you for coming to talk to us and explaining so clearly from first principles, but without patronising us, exactly what the issues are and the opportunities for ways forward, and dragging Egyptology kicking and screaming into the late 20th century, early 21st. It's been brilliant way to end the working week. So thank you very, very much.
Thank you.
Thank you.